Kia ora Year 12. This is question 5 from last week's school exam. So it's paper 62, March 2021, and it's all about sums and linear combinations of random variables. So this question was either incredibly well done with people getting 10 out of 10 or incredibly not well done with people getting usually 1 or 2 out of 10 from doing something right with a normal distribution. It's absolutely crucial that you understand which situation of 2 situations we're dealing with to be able to safely even pass stats 2. So if you didn't get 10 out of 10 in this question, I don't want you to turn this video off just yet. We've given a situation about the volume of juice in large and small bottles, and we're told that the large bottles are distributed normally like this and the small bottles normally like this. So I'm going to start off straight away by calling the large bottle L, and its distribution is this one here. Right, so the mean is 5.1 litres, and the variance, that's the second number given, is this. The small bottles are also normally distributed, and they have a mean of 2.51 and a variance of 0.0036. So the first question asks us about the total volume of juice in 3 randomly chosen large bottles and 4 randomly chosen small bottles. If you're having trouble with this, I want you to just draw a picture like this of what we've got varying, right? So we've got 7 things here that have got variability about them. We've got the first bottle, the second bottle, so the third, so these are the large ones, first large one, second large one, third large one, and then the small bottles, S1, S2, S3, and S4. So to find the variance of the total, well, the total is L1 plus L2 plus L3 plus S1 plus S4. So the variance of T is equal to the variance of L1 plus the variance of L2, and so on, assuming that they're independent, right? But we don't need to worry about that at this stage in our maths. So if they're not independent, we have to do some other things. But in general, if we're in an A-level problem and we're finding the total and it's the sum of random variables, then the variance is just going to be, for the large ones, it'll be 3 times the variance of the large ones plus 4 times the variance of the small ones. And that gives me, what do we get? We get 0.045 for that. And we know that the expected value, the average, will be 3 times the large ones. So it'll be 3 times 5.1, and it will be 4 times 2.51. So that sets me up to say that the total will be normally distributed, I'll come back to why that is in a second, with these parameters. So the mu for the total random variable 25.34 and the variance of 0.045. The reason we can assume that the total is also normal is because in this question we know that the shape of the distribution is normal for both of those. All right, so that's the first part done, and then in the question what we're asked to do is to figure out the probability that the total volume is less than 25.5 litres. So the trouble in this question really came in that first bit of setup. But some of the working that I saw for the second part was also not very good. So we should be seeing something like this. The probability that we want is that the total is less than 25.5. So let's over here work out what my Z value is for that. Well, I take my 25.5, right, and draw a picture if you have to. There wasn't enough of that either. So there's 25.5 and there's my mean at 25.34. So this is my total picture, and now my Z picture says, how do I translate that total into a standard normal? Right, so this is going back to very easy AS work, right? So the top line, the numerator, is the difference between the mean and the 25.5, and the denominator is the standard deviation, which is the square root of 0.045. So that gives me a Z value of 0.754. So good working for this question looks like this, right? We should have something showing my Z calculation. We should have a probability statement, P bracket something. Okay, this is pretty basic stuff that we've just got to fix up. And then that is equal to the probability that Z is less than 0.754. Now drawing that picture, which you don't have to do once you're confident, but it will help you when you're setting out. So if we just draw that Z picture, this is the area we're looking for. It's in exactly the right format for my table, so it's going to be phi of 0.754. Now we go into our normal table, which is not here, sorry, it's in your table sheet. So looking that up in my normal tables, I should get straight away to a value of 0.7 0.75. And I want to give that answer to 3 significant figures. Okay, so that's the first one done. Right, so the key thing to get out of that question, again, is that I'm adding up 7 bottles of juice. So my variance is the sum of those 7 variances. In the second question, it's quite a different situation. We're looking at one randomly chosen large juice bottle and another randomly chosen small juice bottle. And we want to figure out the probability that the volume of juice is at least twice the volume of large bottle juice is at least twice the volume of the small bottle juice. So in this case, I'm going to set up a new variable and I'm going to call that D. So D is the difference between the large volume and twice the small volume. And this is a classic linear combination setup. I've only got 2 things that have got variability in here. I've got this one, and then I've got double the volume in this one. So the expected value of the difference is easy. That's just E of L minus 2 times E of S. And when you work that through, you'll get 5.1 minus 2 times 2.51, and that gives me 0.08. Then for the variance, is going to be the variance of the large one minus 4 times the variance, plus 4 times the variance of the small one. The reason for that is the result we had way back when, which is this one here. Okay, this is a classic linear combination question. So working that through gives me 0.0102 plus 4 times 0.0036, giving me a total variance for the difference of 0.0246. And now we're good to go again, right? We're working with a normal distribution, and we're asked to figure out the probability that the difference is positive, right? So the probability that D is greater than 0, it's greater than because we want the large one to be more than twice as big as the small one. So we're trying to find the probability that D is greater than 0. So my Z value here is 0 minus 0.08 divided by the square root of 0.0246. That gives me the probability that Z is greater than negative 0.510. So sketching that, we are looking for this probability back here. The tables won't give me it in that form, so we have to manipulate it a little bit. So again, if you're prone to making mistakes in these questions still, it is well worth taking the time to just draw that picture out. So the area we want is going to be the area that is above positive 0.51. So hang on, we don't want, I've drawn the wrong picture here, haven't I? Let me just fix this up. So again, this is why you draw the pictures and you check, right? So I want the probability that Z is greater than this number here. So I want all of that. The way the tables are going to give that to me is this. So that's equal to the probability that Z is less than positive 0.510. And that's equal to phi of 0.510, which comes straight out of my tables, and I get from that to 3 significant figures, 0.695. Okay, so thanks for watching. I went through that pretty slowly on purpose because there are 3 things I want you to get out of this video. So hopefully someone is still out there watching. Please send me an email if you got this far. The 3 things are these. In the first question, we are working with a total volume where we've got 7 things varying, right? Variation in each of 3 large bottles and in 4 small bottles. So I'm adding up 7 variance numbers. In the second question, I have to set up a linear combination of 2 random variables. So in that case, my variance is using this result, that the variance of AX is equal to A squared var X, right? And the variance of negative BX is equal to the variance of negative B squared var X, which is where we get the result of adding the variances, even though we've got a difference. So they're the first two obvious things, but the third thing in here is that you really need to watch that you're showing good working. So I want to see statements where I've got P something something. I want to see clear calculations of Z values, and I want to see some diagrams if you're having trouble using your normal tables. Thanks for watching. I will slowly make my way through the rest of the paper sometime today.